Okay, we're looking at solving combined inequalities. There are two types of combined inequalities that we're going to look at. One is conjunction, which is similar to a conjunction that you have in English, and the other is a disjunction. Two sentences joined by the word and is a conjunction. To solve a conjunction of two open sentences in a given variable, you find the values of the variable for which both sentences are true. The graph of a conjunction consists of the points common to both of the graphs where the graphs overlap. So basically what that means is you're going to have two inequalities and they can be joined by the word and, or they can be written like this. And we've seen some like this already where you just have two inequality symbols and you have the variable in between. Well, these are conjunctions, and so you're looking for solutions that make both inequalities true. That's where the and comes in. Both have to be true. So a lot of times what will happen is you'll have the graph of one and the graph of the other, and you're looking to see where they overlap. So if we look at this first one, we have -2 is less than x, and I can rewrite that as x is greater than -2. Notice how the open side is towards x. As long as I keep the open side towards x, I can flip it over. So if I have x is greater than -2, I'm going to put an open circle. I'm going to put it above -2. I'm not going to put anything on my graph yet because I want a graph where they overlap. So if I put it up here, x would be greater, which means it would continue on in that direction. My other inequality says x is less than 3. So I come to where 3 is, and I'm going to put an open circle there, and I would graph it this way because x is less. Now I'm looking to see where they intersect or where they overlap. So -2 is a solution for the second inequality, but not the first. So I'm going to have an open circle at -2. And 3 is a solution of the first inequality, but not the second. So I'm going to have an open circle there. But all the numbers in between are solutions for both of them because they overlap. So that is going to be the graph of that conjunction. Okay, so these are the solutions that make both of these inequalities true. I'm then going to look at a disjunction. So two sentences joined by the word or is called a disjunction. So to solve a disjunction of two open sentences, you find the values of the variable for which at least one of the sentences is true. That is, one or the other or both are true. The graph consists of all points that are in the graph of one or the other or both. So basically you're taking two inequalities, you're graphing them both on the same number line. We don't care if it overlaps. It's just everything that gets shaded in. So if we look at this first one, we have y is greater than 2 or y is equal to 2. We normally read it like this. Y is greater than or equal to 2. Okay, so we've been doing disjunctions for a while now. Okay, so we're going to graph this, and I'm going to go ahead and graph just both of these separately. But because it's a disjunction, I'm going to go ahead and graph it on the number line. So I have an open circle at 2. Y is greater than that. So I would go ahead and shade this. And then I also have that y is equal to 2. So I'm going to go ahead and shade in that circle. Well, this is just the graph of y is greater than or equal to 2. Okay, so disjunctions are pretty easy. You just graph both inequalities on the same number line. Conjunctions are where you have to look for the overlap. Okay, so let's look at this conjunction here. We know it's a conjunction because it has two sets of inequality symbols. But notice that there's not just a variable in between. We have x minus 2. So we got to get x by itself. So what I'm going to do is I need to add 2, and that would cancel out the 2's here. But I also have to add it here, and I also have to add it here. So just like an equation where you do what you do to one side, you have to do to the other. For this, you have to do the same thing to all three parts. So when I add this, I'm going to get -1 is less than or equal to, this is just x, and it's going to be less than 6. So this is my conjunction. I have -1, and it's going to be a closed circle. And I have 6, and it's going to be an open circle. And x is between, because x is greater than -1, but it's less than 6. So I'm going to fill in between here. So that's the graph of that conjunction. If I look at this, now I have a disjunction, and I know it's a disjunction because there's an or. I'm going to simplify each of these first before I start to graph. So here I need to get w by itself, so I'm going to add 1 to both sides. So I get 2w is less than 4. And then I'll divide both sides by 2, so I get W is less than 2. And before I start to graph this, actually I can go ahead and graph it because I've got numbers here. I would have an open circle at 2. W is less than that, so I would shade in this direction. And then if I look at the second one, I'm going to subtract W from both sides. So I get 2W is greater than or equal to 10. If I then divide both sides by 2, I get W is greater than or equal to 5. So I'm going to have a solid circle at 5, and I'm going to shade this way. So that is that disjunction. If we look at our proof, I have -2 is less than m plus 1, which is less than or equal to 4. This is a conjunction, so I'm looking to see where they overlap. I'm going to write it out here so I can simplify it. I need to get m by itself, so I'm going to subtract 1 from all 3 sections. So I have -3 is less than m, which is less than or equal to 3. So I'm going to have a open circle at -3, and m is greater than that, so it's going to get shaded that way. And I'm going to have a closed circle at +3, and m is less than that, so it's going to be shaded this way. So the inside part gets filled. My last example here, I have a disjunction because of the or. So I'm going to simplify each of these separately, and I'm going to write them down here. So if I do this one, I need to get the y by itself, so I'm going to subtract 1, and then I'm going to divide by 5. So y is less than -1. So I have an open circle at -1, and I shade in this direction. And if I do the second one, I have 4y greater than y plus 9. I'm going to subtract y from both sides, so I have 3y is greater than 9. Divide both sides by 3, so I have y is greater than 3. So I have an open circle at 3, and I shade to the right. Okay, if we look at the classwork, there's a couple that I want to go over. The first one is number 3. And number 3, we have actually a conjunction, but we need to simplify to get y by itself in the center. So we're going to add 2 to all 3 parts. And I'm going to have 0 is less than y, which is less than or equal to 3. Okay, so y is greater than 0, but it's less than 3. So I'm going to have it. Notice there's no numbers here. I'm just going to throw in a 0, throw in a 3. It doesn't matter how far apart they are as long as they're in numerical order. I'm going to have an open circle at 0, a closed circle at 3, and I'm just going to fill in between. If I look at number 7, okay, this is a disjunction because of the or. So I'm going to simplify each side. So here I'm going to subtract 5 from both sides, and I get h is less than or equal to 7. Because I don't have any numbers here yet, I'm going to go ahead and simplify this one as well. So I'm going to subtract 5, and that's going to give me h is greater than or equal to -3. So now I know my 2 numbers. So I'm going to make sure they're in numerical order. There's my -7, my -3. H is less than or equal to, so I'm going to fill it in a solid circle and shade to the left. But h is greater than -3, so another solid circle and shaded to the right. Okay, remember with a disjunction, you just graph them both. If we look at the back now, number 9, another disjunction. And again, I'm going to simplify each one first, and then I'll figure out where my numbers go. So here I'm going to add 5 to both sides. So I get 2d is less than -2. Divide both sides by 2, and I have d is less than -1. Here I'm going to add 5 to both sides. Oops, don't want to do that. And divide both sides by 2. And I want to turn this around. So the open side is next to the D. So I just need to make sure when I turn it around that my open side stays with the D. So my numbers are -1 and 6. Okay, make sure that I have them in the right order. This is a disjunction, so I can just graph them both. D is less than -1, so it's an open circle there. And it's greater than 6, so it's an open circle there. If we look down at the next section, there aren't any graphs because they don't want us to graph them. They just want us to simplify these. So we're going to go ahead and do that. So this one again is a conjunction. I need to get the y by itself, so I'm going to subtract 3 from each section. So I have negative 5 is less than negative y, which is less than or equal to negative 2. I don't want negative y, I want positive y. So I'm going to divide everything by negative 1. So I have 5 is greater than. Remember, I have to change my inequality symbols. Whoops, and I didn't do that one. So it's 5 is greater than y, which is greater than or equal to positive 2. Okay, and we're not graphing it. This one is a conjunction, and again, we need to get the x by itself, so I'm going to add 1 to all three sides. So I get negative 6 is less than negative 3x, which is less than or equal to 9. I need to get x by itself, so I'm going to divide everything by negative 3. So this becomes 2. I have to flip my inequality. This becomes x. That gets flipped, and there's my solution there. The last one I want to look at, actually there's two more I want to look at. Number 17, this is on the third page. This is a conjunction, and we're going to simplify each side separately. So here I'm going to have my variables on the left-hand side. It just makes it easier for me. So I'm going to add 2y to both sides, which will give me 9 plus y is less than or equal to 3. And then I'm going to subtract 9. So I have y is less than or equal to negative 6. Yeah, negative 6, right? Did I do that right? This is where I start to doubt myself. Okay, I think that's right. All right, here I want to have y by itself, so I'm going to add 1. I get negative 2y is greater than or equal to negative 4. Divide everything by negative 2, so I'm going to end up having to flip my inequality again. So y is less than or equal to negative 6, and y is less than or equal to 2. Okay, the last one I want to look at, this is not on the regular algebra homework. They only go up to 19, so you guys can go do something else now. Honors algebra, I wanted to do number 20 with you. Okay, so this one says, find the value of k so that the solution set of k minus 5 less than or equal to x minus 6 less than or equal to 3. So here's my inequality. And what I want to know is, I want to find k, but I want to find k so that the solution is the same as the solution set for this conjunction. So what I need to do first of all is find the solution for the conjunction. So let's start with that. So I have 3x minus 7 is less than or equal to 2 times 1 plus x. And so I'm going to do the distributive property. Then I'm going to subtract 2x from both sides. And I'm going to add 7 to both sides. And I get x is less than or equal to 9 for that first part. Then I'm going to do the second part of my conjunction, which is 5x minus 7 is greater than or equal to 23. I'm going to add 7 to both sides. And I'm going to divide both sides by 5. So I have x is greater than or equal to 6. And I'm going to rewrite this so it's in the right order, because I want the 6 here and the 9 there, because that is numerical order. So x is less than or equal to 9, and x is greater than 6. So the open end is towards the x. So when I rewrite it, I'm going to make sure the open end is towards the x. So x is between 6 and 9, and it includes 6 and 9. Now I'm going to take this with the k, and I'm going to simplify it so that I have x in the center by itself. Now let's see what happens. I need to add 6 to all three sections. So I have k plus 1 is less than or equal to x, which is less than or equal to 9. And if I compare these, if I write it over here, let me line it up better. These two have to be equal to each other. So k plus 1 needs to equal 6, so k would have to equal 5. So the value of k that will give this inequality the same solution as this one is 5.